In this video, we're going to discuss integration of trigonometric functions. Okay, let's start. So we have a total of 10 formulas. But first, let's establish that uh, u is a differentiable function. It can be in terms of x or in terms of y. It can be any expression. Okay, so we'll be using u as a placeholder for all the arguments that we will be encountering sa mga formulas. Okay, so again, total of 10 formulas. The first 6 are the first 6 are obtained kumbaga from differentiation rules. Okay, this correspond to the 6 formulas correspond to uh, the 6 trig functions, okay, and their derivatives. Okay, so if you can still recall, if we differentiate cosine, that's negative sine. Okay, therefore if we take its antiderivative of sine, it should be negative cosine. Okay, direct result ng differentiation rules. Kasi nga opposite lang 'di ba ang uh, indefinite integration to be particular, and differentiation. Okay? So, that's the first 6. These are the first 6 formulas. Again, direct result lang ng differentiation of formulas. And then we have here formulas for or antiderivatives ng tangent and cotangent. So for both tangent and cotangent, we have, so each of them have two, tawag nito, two equivalent na mga formulas. Okay, so for example, sa tangent, we have here, one formula is ln secant, which is equivalent to negative ln cosine because of how logarithmic functions work. Okay, so later on we'll see bakit naging equivalent itong ln secant and negative ln cosine. So basically ano lang, property ng logarithmic functions. Okay, the same also is true for cotangent. Okay, and then the last two formulas, so we already have sine, cosine, tangent, and cotangent. The last two formulas are for secant and cosecant. Okay, so again, first 6 are direct result lang ng or obtained lang from differentiation rules. Tapos 7 and 8 can be obtained by using the ratio identity ng tangent and cotangent. Tapos for secant and cosecant, medyo relatively difficult ang pag prove ng formulas or pag-obtain ng formulas. So let's see. Try natin first ang tangent. So we'll try to prove, alright, that integral of tangent of u du is equal to ln secant of u plus c, or negative ln cosine of u plus c. Okay? So again, class, remember that if you want to tawag nito, to prove or obtain an integral, or for example in this one we want to prove that indeed the integral of tangent of u du is equal to ln secant of u plus c, or negative ln cosine of u plus c, or any integral in general. Okay, we can always start from the right hand side of the equation. Okay, and since this is the antiderivative, to prove that these two are equal, then we can just simply take its differential. Isolate nyo ang right hand side of the equation, tapos take its differential. So makuha ninyo ang expression on the left hand side of the equation. Okay, so what I'm going to try in this case is we assume that we don't know na this is the equivalent ng integral ng tangent, or these are the equivalent ng integral ng tangent. Okay, so we'll start with the left hand side of the equation, and then again assuming that we have no idea what is its equivalent integral. Okay, so we'll start from scratch kumbaga. All right, so again, for this integral tangent and for cotangent, we apply ratio identity. Okay, so for this particular example, tangent is equivalent to sine of u over cosine of u. Tama ba? is of course du. Okay, and then from here we can apply u sub. Okay, and since nagamit na ang u, we'll use another variable, let's say v. Let v equals, in this case, the denominator cosine u. Okay, and then take its differential. Ang differential kasi nito is negative sine u du. Tama ba? Which is already present in our integral. Kulang na lang ng negative 1. Tama ba? So, we put negative 1, negative sine u du. This will satisfy dv, right? So, ito. We multiplied negative 1, so we have to divide by negative 1, or simply that's equivalent to just multiplying again negative 1 para ma-offset lang, ma-neutralize. Okay. And then, as is lang cosine of u. And this will now take the form, ang numerator is dv, tama ba? So, dv. Tapos, ang denominator is v, right? So, we now have dv over v. This is integrable using the ln formula. Or this is an example of integration resulting to ln function, right? So, we now have negative ln v, where v is cosine u, right? So, plug in cosine u, of course, plus c. Okay? So, what we obtained here is the second formula. This one, negative ln cosine u plus c. Okay? And then we'll check if this is also equivalent to the first formula. Okay? So, basically, ano lang class? Power property lang ng logarithmic functions. Okay? So, recall lang, if we have ln of, for example, m raised to n, this can be written as, or in other words, we have here ln function of an expression. The argument is m. Tapos this is the argument is raised to a certain power n. Okay? Itong power ng argument can be written as numerical coefficient ng whole ln function. Tama ba? So n ln of m and vice versa. Okay? So itong negative 1 from negative ln cosine u can be written as the exponent of the argument cosine u. Okay? So maging ln cosine u raised to negative 1. Tama ba? Plus c. Okay? And then, if we convert this to positive exponent, itong negative 1, so we'll have to transfer cosine of u in the denominator. Tama ba? So, transfer na ko. Balinda dali. So, initially, we have ln. Again, we have ln cosine of u raised to negative 1 plus c, right? So, ln of what? Convert this to positive exponent, so this will be, or this will give us 1 over cosine u. Tama ba? Plus c. Then 1 over cosine u, this is reciprocal identity of secant. So ln secant u plus c. And this is now the first formula for tangent. Okay? So next, let's try to, by the way, this technique also is also applicable for cotangent. Okay? So gawin nyo lang, ratio identity pa din, pero for cotangent. So ang cotangent naman is cosine divided by sine. Okay? And then you employ the same techniques. Alright? Next one, let's try to prove the integral, or let's try to derive the integral of secant. Okay? And then later on, you can try to prove the integral of cosecant. Okay? You will just apply the same technique that we will be using for secant. Okay? So let's start for secant. Our goal is to prove that this is, or this holds true for secant. Okay? So let's start secant. If we try to apply the same technique previously used from tangent na integral using identity. So in this case, ang secant kasi reciprocal identity is 1 over cosine. Tapos, this will become 1 over cosine du. Tapos, medyo ano na. Kumbaga, dead end na. So, from 1 over cosine u du, kumbaga, we have no way of proceeding with the integral. So, what we can do for secant, we can manipulate by dividing and multiplying an expression. Okay? Na dapat equivalent to 1. Okay, and let's see. For secant, for this one, pinaka-applicable is multiplying and dividing secant of u plus tangent of u na expression. Okay? Sige. Why is this the case for secant? Let's see if we simplify, if we distribute. Okay, so what will happen is that in the numerator, we'll have secant squared u. So, nakadistribute lang ang secant. So, secant squared u, tapos secant u tangent u. And then, sa baba is lang, secant u tangent of u. And then, applying u sub, or in this case, let's use v. For this one, we'll let v be equal to the denominator, itong secant u. Kasi if we take its differential, so we'll see later. So, v equals secant u tangent u. Taking its differential, it will give us, so, derivative ng secant is what? Product ng secant u and tangent u. Plus, derivative ng tangent is what? Secant squared u. Tama ba? du. And this expression, if you check from our integral, so it's similar to, or it's equivalent to, or it's equal to the numerator, the expression in the numerator, right? Secant squared u, secant u tangent u. Therefore, it immediately satisfies our dv. Okay? So, we now have an expression in the form dv over v. Okay? Yung sa numerator is dv, sa denominator is v. Therefore, integrable using ln formula. Okay? So, that it will give us ln of the denominator, ln of secant u plus tangent u plus c. This is now the formula for integral of secant. Okay? Yan. So, you try proving the integral for cosecant. You apply the same technique, multiplying an expression equivalent to 1. So, you apply the same pattern, and then you'll eventually obtain the equivalent integral for cosecant. Okay? Sige. So, let's look at some examples. Let's first have a very simple example. So, we have your integral of sine 3x dx. Very straightforward. You just apply the formula, but applying the formula, of course, coupled with u sub. Okay? Kasi nga u sub class is used to supplement the formulas that we have. Okay? U sub is, kumbaga, it is used to satisfy the formula that we are that we want to use, or that is applicable for a certain integral or given integral. Okay? So, in this case, we let u be 3x. Therefore, du is what? 3 dx. Okay? So, ayan. We now have what? Itong sine 3x, 3 dx is in the form sine u du. Okay? So, if it takes the form of this expression, then we can now integrate. Kasi we have a formula, diba, for integral of sine u du, which is negative cosine u plus c. So, just apply the formula. Then, this is now the integral. Next is also a straightforward integral. Again, u sub for the argument 5x, which gives us du equals 5 dx. Right? So, plug in 5 dx, then neutralize by multiplying 1 over 5. So, this is now in the form secant u u is 5x. Secant u tangent of u, du is 5 dx, right? So, integrable using secant u tangent u formula. This is equivalent to secant u plus c, right? Where u is 5x. And of course, don't forget the neutralizing factor, 1 over 5. Okay. Next. All right. So, this one is not as straightforward as the previous two examples. This requires manipulation first. Okay, this the same way as we simplify algebraic expressions. Now we apply algebraic techniques like factoring, the distributive property, or division operations, so on and so forth. So we can also do that with trigonometric expressions. Okay, so for this one, we have a binomial in the numerator and a monomial in the denominator. We can just simply apply distributive property. So kumbaga, distribute niyo ang sine squared x for each of the term in the numerator. So we'll have sine x over sine squared x minus cosine x over sine squared x, tapos simplify lang. And then apply trigonometric identities. Okay? So what happens is that, again, we have here sine x divided by sine squared x. So mag-cancel out ang isang sine x so that we are left with 1 over sine x. Okay? And then cosine x over sine squared x, wala namang ma-cancel out. Okay? And then we apply ratio and what do you call this? Reciprocal identity. So 1 over sine x reciprocal of reciprocal identity ng kumbaga ng cosecant. Tama ba? And then for cosine x over sine squared x, we can write this as so again, we have cosine x. Isolate muna natin ang cosine x over sine squared x. This can be written as we can group together cosine x and sine x. So cosine x and 1 sine x. Then the other sine x, naka-isolate lang. Okay? So equivalent lang siya, di ba? Cosine x over sine x times 1 over sine x. That's equivalent to cosine x over sine squared x. Okay? And then we apply identities. For cosine x and sine x, this is the ratio identity ng cosecant. And then reciprocal identity, 1 over sine x, that's, erase natin. Again, cosine x over sine x, it's the ratio identity ng cotangent. Okay? And then reciprocal identity, itong 1 over sine x, that's cosecant x. Okay? So, next line would be something like this one. 1 over sine x again is cosecant x, and then cosine x over sine squared x is this expression. So, ayan. Nauna lang pagkasulat ang cosecant x. Pero still the same. Okay? And then, this line is now readily integrable. We have a direct formula for cosecant and cosecant x cotangent x. Tama ba? So for cosecant, that's ln cosecant minus cot, right? Or the other formula, negative ln cosecant plus cotangent. We usually use this one, ln cosecant minus cot. And then cosecant x cot x, its antiderivative is what? Negative cosecant. So that's why it became positive cosecant. Negative times negative. So naging positive cosecant x plus c. Okay? So this is another fun answer. Alright, number 4. This one, this requires another identity, trigonometric identity. So in particular, it's the double angle identity of sine. So like, recall lang natin, sine 2 theta equals, this is equivalent to 2 sine theta cosine theta. Tama ba? Where theta here is just a placeholder. Tama ba? It can be any other expression. Okay? So in this case, ang expression in question is itong 1 over or 1/2 x. So theta equals 1/2 x for this particular example. Okay? So mangyayari, class, if we plug in 1/2 x, so sine 2 times theta, theta is 1/2 x, equals to sine 1/2 x cosine 1/2 x. Okay, so simplify lang. 2 times 1/2, that's 1. So sine x equals, as is lang sa right hand side, 2 sine 1/2 x cosine 1/2 x. Okay, and then since we only want sine 1/2 x cosine 1/2 x, then we can cross multiply itong 2. So maging sine x over 2 equals sine 1/2 x cosine 1/2 x. Okay, so it will give us this one. Okay, so sine x over 2 or 1/2 sine x. Then simplify lang. We have a itong 1/2 nasa denominator, so we can rewrite it as just 2 sa taas. Tama ba? And then reciprocal identity sign for sine cosecant x. And then cosecant, of course, it's directly integrable. It's we have a direct formula for this one. It's negative, or I mean it's let's use the positive na ln. So ln cosecant u, or in this case u is x. So ln cosecant x minus cot x plus c. Okay, so that's the final answer. Next problem, number 5. We have here the integrand is cosine cube x all over 1 minus sine x. So this one, it requires a bit more manipulation as opposed to, or I mean, compared to the previous examples. Okay, so for this one, I guess we have at least 2 ways to start the simplification process. So let's try. For this one, I applied this technique. I mean, we can factor out cosine x from cosine cube x so that it becomes cosine squared x cosine x. Okay, and then cosine squared x can be converted to its Pythagorean identity. So it's equivalent to 1 minus sine squared x. Okay, this is from Pythagorean identity class. Cosine squared x equals 1 minus sine squared x. And this expression, 1 minus sine squared x, is a difference of 2 squares. Okay, so it's factorable. The factors are 1 minus sine x and 1 plus sine x. So here we can now cancel out 1 minus sine x so that we are left with 1 plus sine x cos x dx. Okay, and then this expression here, 1 plus sine x cos x dx, has at least 4 valid antiderivatives, kumbaga. Okay, so it depends on what you apply for this one. So for the first valid antiderivative for this one, we can use u sub directly. Okay, so if we apply u sub directly, u equals this expression here, 1 plus sine x. Its differential is what? Cosine x dx. So automatic na ito, cosine x dx. So we now have u raised to n, where n is 1 in this case, u raised to n du. So basically power rule lang. So yan, 1 plus sine x, quantity 1 plus sine x squared over 2 plus c. So power rule lang. Tama ba? And then, before we try to evaluate this one using other techniques, let's go back to cosine cube x over 1 minus sine x, to the original na integral. So again, first technique applied here is by factoring out cosine x and then converting cosine squared x to its equivalent na Pythagorean identity. Okay, or, so let's wait lang. Or, sige, start integral cosine cube x 1 minus sine x dx. cosine cube, as is muna, cosine cube x, 1 minus sine x. So here we can multiply and divide the conjugate expression for 1 minus sine x, which is 1 plus sine x. Okay? dx. Alright? So just distribute. We have here cosine cube x as is muna sa taas. So cosine cube x times 1 plus sine x. And this is dx. Sa baba, we have here 1 minus sine x, 1 plus sine x. This will result to a difference of 2 squares. Tama ba? So maging 1 minus sine squared x, right? And then of course, so we have here cosine cube x, 1 plus sine x dx. 1 minus sine squared x, of course, is the Pythagorean identity of cosine squared x. So cosine squared x, cancel out ang cosine squared x, maiwan is what? Cosine x 1 plus sine x dx. Okay, so which is the same as this one. Okay, so we can proceed. Similar also to this one, pwede mag-use sub, or sige, let's try another way. What are other ways we can integrate this one? So we already have one, yung direct na use sub, or we can distribute, diba? So if we distribute cosine x, this will become cosine x plus sine x cos x dx, right? And then we have two terms now. Cosine x is readily integrable. We have a formula for cosine. Tama. However, for sine x, cosine x, we have several. We have a few ways also. We have another. We have a few other ways to integrate sine x cos x. It's either you just directly apply u sub, so you can let u be equal to sine x, du is cosine x dx, or another u sub, but instead of sine x being u in this way is cosine x na naman. So u equals cosine x, tapos ang du is negative sine x dx. So pwede pa rin. Or you can before you apply u sub, you can apply double angle identity for sine. Okay, kasi nga, di ba, sine 2 theta equals sine, 2 sine theta cosine theta. Okay, so itong sine x cos x is similar to this expression, kulang lang ng 2. Tama? So kumbaga, cross multiply lang ang 2 para makuha ang sine theta cos theta. Tapos you can integrate immediately itong sine 2 theta, integrable naman, u sub lang 2 theta, tapos so on and so forth. Tama? So you try this one, and then you'll get a different form of the integral, but valid pa rin naman na antiderivative. Valid pa rin naman na integral. Different forms lang, pero ang difference lang nila is ang constant, which makes them valid antiderivatives kasi ang difference lang nila ang constant. Wala may problema sa constant, diba? They can be just represented as c. So kumbaga practically similar lang yapon sila. Sige, pwede na to siya i-solve. Itong ipakita. So integral of cosine is sine, right? Sige. We already have the first, diba, kanina yung direct u sub. So let's call this method number 2. So cosine is positive sine, so sine x plus let's try u sub where u is sine. So du is what? Cosine x dx. So automatic na, diretso na, right? So maging ano to sa power property, power rule. So u raised to n is 1, tapos du ang cosine x dx. So sine squared x over 2. plus C. That's the first one. Tama ba? Second, I mean, this is the second one kasi meron tayong first kanina using direct na U sub. Third, let's try U sub pa din. Pero instead of sine, gamitin natin yung cosine. Cosine x du is what? Negative sine x dx. Okay? So mag-negative ito siya dapat para ma-neutralize ang negative. Therefore, ang cosine x sin x pa din ang integral. Pero mag-negative ito siya dapat. So negative cosine squared x over 2 plus c. Okay? And then, so this is another form. This is another valid antiderivative kasi we followed the proper steps naman. We applied the correct formulas naman and properties. So valid pa din siya. We'll see later on bakit siya valid, no? We'll check by manipulating each of the integrals if similar lang ba sila. Okay? And then fourth one, let's try the fourth one by converting muna itong sin x cos x into its double angle identity. So again, from the double angle identity, so maging ano siya, sin x cos x is equal to sin 2x, tama ba? Over 2. Right? Therefore, the integral can now be written as what? Itong sin x cos x can be written as, sige, sulat na to. Sin 2x over 2. Which is readily integrable naman, di ba? U sub lang, 2x. So, sulat na to, tari. U is 2x. Du is what? 2dx. So, multiply lang ng 2, tapos divide ng 2 para ma-neutralize. Alright? So, we have here, ang cosine x, same pa din. Antiderivative niya is what? Positive sine x. And then, 1/2, ito, may 1/2, constant multiple rule, pwede na siya i-factor out from, sa second term lang. And then, times another 1/2 kasi nga mag-neutralize because of this one, this expression, du equals 2dx. So 1/2 times 1/2 naging 1/4. Okay. So over 4. And then derivative, antiderivative ng sine is what? Negative cosine. So negative cosine of 2x plus c. Okay. So this is another valid na antiderivative. Ayan. Okay. Sige. Check natin if they are they are equivalent lang ba. Sige, let's start with the previous na integral is what? Ito, 1/2 sine, 1/2 times the quantity 1 plus sine x squared. Okay? We can start with this one. Pwede natin siya expand. Diba? So, let's try. We have 1/2. And then expand yung sa numerator. So, this will become 1 plus 2 sine x plus sine squared x. Okay? Plus c, of course. And then, distribute 1/2 for each of the terms in the numerator. Okay? Sige. Tiri lang ako isulat sa taas. So, ito, sulat ako sa taas, class. So, 1/2, distribute lang itong 2 in the denominator for each of the terms in the numerator. So, we have 1/2 plus 2 sine x over 2. So, mag-cancel out ang 2. So, sine x. Tama ba? Plus sine squared x over 2. Over 2 plus c. Okay? And then, remember that constants can be combined, or all the constants can be combined to form the overall na constant. Therefore, kaning 1/2 can be combined with c to form the overall na constant of integration. Okay? So, we have sine x, ba? Plus sine squared x over 2 plus c. Okay? So, what we've done here is we converted itong 1 plus sine x raised to 2 over 2 plus c into this form. Sine x plus sine squared x over 2 plus c, which is similar to this one. Tama ba? Sine x plus sine squared x over 2 plus c. Okay, so okay na ang dalawa. No, na-prove na equivalent sila. Let's try itong sa third, kung paano siya naging equivalent. Okay, sige. Wait lang. Erase ko muna. Okay. Sige. So, we can start with this one. Ito na expression. No? So, sine x plus sine squared x over 2 plus c. Okay? And then, we can use Pythagorean identity for sine. So, sine squared using Pythagorean identity is what? Equal to what? 1 minus cosine squared. Tama ba? This is all over 2 plus c. And then distribute 1/2. So this becomes sine x plus 1/2 minus cosine squared x over 2 plus c. Okay? And then again, constants. So itong 1/2, combine natin sa c. So maging sine x na lang plus, minus cosine squared x over 2 plus c. Tama ba? Which is similar to this one. Equivalent to this one. Sine x minus cosine squared x over 2 plus c. Okay? So, okay na ang third. Let's try naman itong fourth. We can still use itong sa second na integral. So, erase na ako. So, erase. We can still start with itong sa sine x plus sine squared x over 2 plus c. Pero instead of Pythagorean identity, we'll use tawag nito, double angle identity ng cosine. Okay? So, sine x plus, ang sine squared x kasi is what? Anong double angle identity niya? Double angle identity in terms of cosine. It's 1/2 1 minus cosine 2x. Okay? From the double angle identity. So, plug in natin ang double angle identity. So, 1 minus cosine 2x all over 2 plus c. So, sine x plus, so itong 2 sa denominator in the overall na numerator can be transferred in the overall na denominator, diba? So, 2 times 2 is 4. Then, 1 minus cos 2x plus c. Okay? So, sine x now, the integral now converted na sine x plus, distribute itong 1/4. So, plus 1/4 minus cosine 2x over 4 plus c. And then, constants, itong 1/4 can be combined with c para maging overall na constant. So, sine x minus cosine 2x over 4 plus c. Right? Equivalent to this one. Okay? Therefore, the four forms ng antiderivative na nakuha natin depending on the method that we used are all valid na anti-derivatives. Kasi they are equivalent lang man. I mean, they are practically the same. Ang difference lang nila isang constants. Kasi may mga constants na na-generate tapos na-combine lang sa C para maging overall constant of integration. But again, class, each of the, I mean, all four na integrals, all four answers for this particular na problem are valid na anti-derivatives. Okay? Similar lang sila. What? So, to further demonstrate ito na case, no? Different forms pero valid pa din na integrals. Okay? So, let's try, let's go back to algebraic na algebraic na expressions. So, we have a simple na integrand, x plus 1 raised to 2 lang na integrand. But we have at least two ways to solve this integral. Okay? And this will generate two different forms ng integral. So, first one is to directly apply u sub, right? So, u equals x plus 1. Du is dx, just dx, tama ba? Therefore, we now have x plus 1 is u. So, u raised to n is 2. So, u raised to n du. Du is dx man. Tama? So, power rule lang. Okay? So, power rule lang, this will become x plus 1 cube over 3. Oops. Wala din siya naka. So, this will give us what? X plus 1 cube over 3. So, very straightforward lang. Plus c. Tama ba? That is if we apply u sub directly. Right? And another way is to expand. No problem naman sa pag-expand kasi I mean 2 lang man ang power. So very easy lang i-expand. Kung 3 pwede gihapon i-expand. I mean kung raised to 3 cube ba ang expression ko raised to 3 tapos binomial lang man pud siya, so no problem sa expansion. Okay? Pero pag medyo complicated na raised to 4 or more siguro tapos ang expression inside is trinomial or four terms na polynomial, so medyo complicated na ang expansion, medyo taas na ang expansion, so we'll have to find another way to evaluate the integral. Pero for this one, kasi very simple lang man siya, binomial lang tapos raised to 2 lang, so very short lang din ang iyang expansion, no? So if we try to expand before we integrate, so x plus 1 squared, that's x squared, tama ba? Plus 2x plus 1 dx. Okay? So this will just give us a trinomial, which is relatively simple lang na expression. Okay? And then from here, we can proceed with the integration for each of the terms. So this will give us x cubed over 3 plus, this is 2x squared over 2, so mag-cancel out ang 2. So plus x squared, and then plus x plus c. Okay? So we now have two different forms of the same integral. Let's check if both are valid na antiderivatives. I mean, valid siya. That is if we applied the correct na formulas, if we evaluated properly using the applicable na mga formulas, tapos wala man tayo violate na mathematical rules, then you can conclude na tama inyong answer. Pero we have two different forms, so we'll check if if valid ba sila by checking if similar ba sila na expressions. Okay? So we can start with the first one, itong x plus 1 raised to 3. Expand na to siya. So isolate lang natin class. X plus 1 cube over 3 plus c. Okay? So let's try to expand. Binomial expansion, exponent is 3, so 1, 3, 3, 1 sa Pascal's triangle para mas dali. So this is x cubed plus 3x squared, tama ba? Plus 3x plus 1 over 3 plus c. Okay? And then distribute 1/3 for each of the terms in the numerator. So we'll get x cubed over 3 plus, second term, we have 3x squared over 3, so mag-cancel out ang 3. Therefore, x squared na lang, right? And then 3x over 3, cancel out again ang 3, so x na lang, plus 1/3. plus c. Okay. Then again, we can combine this 1/3 with c, so that overall we'll get x cubed over 3 plus x squared plus x plus c. Okay? So similar lang sila. Okay? Therefore, this one and this one, both of them are valid na antiderivatives. Okay? So ang difference lang nila, class, is ang constant. Kasi ang itong sa second na form of the integral, may additional lang siya na 1/3. Okay? Pero basically, kasi constant lang man ang difference nila, they are practically the same lang na integrals. So valid pa rin sila na antiderivatives. Okay? So that ends our discussion for integration of trigonometric functions. You can kindly check out the quiz assignment for Trigo. Pre-recorded lecture video for inverse Trigo functions, resulting to inverse Trigo functions, will be uploaded later. Okay.